During World War II, the line between cruisers and battleships was pushed to its absolute limit. Some cruisers carried so much steel, firepower, and combat equipment that they exceeded every standard that had come before. Today, we will explore the 10 largest and heaviest cruisers of the Second World War, massive war machines that turned the oceans into true steel battlefields. Without further delay, let's begin. 10. New Orleans class, reinforced armor and ammunition protection. Side belt armor. The New Orleans class became heavier not because it was bigger, but because it was better protected. Its side belt armor was significantly thicker than earlier U.S. cruisers, forming a steel shield along the hull. This armor was designed to stop direct shell hits at medium and close range. But thicker armor meant more than extra steel. It required a stronger internal structure to carry the weight without twisting under speed or battle shock. Armored deck protection. Protection did not stop at the sides. The deck itself was armored to resist plunging fire and shell fragments falling from above. Adding armor to the deck increased weight high inside the ship, forcing designers to reinforce the entire internal framework. The result was a heavier cruiser, but one far more resistant to attacks coming from multiple angles. 203mm ammunition magazines. The most dangerous space on any cruiser is the ammunition magazine. On the New Orleans class, the magazines holding 203mm shells were enclosed by multiple layers of armor, blast-resistant bulkheads, and sealed safety doors. These systems added no speed and no firepower, but they were essential to prevent catastrophic explosions after a hit. This was survivability weight, heavy, unavoidable, and critical. Damage control systems. Much of the ship's weight was hidden inside the hull. Watertight compartments, reinforced bulkheads, fire suppression systems, and powerful bilge pumps were all built in to control flooding and fire. These systems allowed the ship to stay afloat even after severe damage. The New Orleans class was heavy because it carried more equipment designed not just to fight, but to survive. 9. Zara class, heavy armor-driven design. Heavy side belt armor. The Zara class was built around armor, not weapons. Its side belt armor was unusually thick for a cruiser, designed to stop direct hits from cruiser-caliber shells. This massive steel belt added enormous weight along the hull and forced the entire structure to be reinforced to carry it safely. Armored deck protection. Armor did not stop at the sides. The deck itself was heavily armored to resist plunging fire and shell fragments falling from above. Placing armor high inside the ship increased top weight, requiring additional structural reinforcement to maintain stability. Reinforced structural framework. Such heavy armor could not exist without a stronger internal skeleton. Zara-class cruisers used reinforced frames and beams to distribute armor weight across the hull. Much of the ship's mass came from this hidden internal structure. Armored combat compartments. Magazines, machinery spaces, and command areas were protected almost to small battleship standards. This level of internal protection increased survivability, but it also pushed displacement far beyond normal cruiser limits. Zara was heavy because protection dictated every design choice. 8. County class, long-range logistics and endurance. Extended fuel storage system. County-class ships were built to operate across entire oceans. To do that, they carried extremely large fuel reserves. Fuel itself is pure weight, and the tanks required pumps, piping, ventilation, and fire protection systems. Long-endurance supply storage. These ships carried large stocks of ammunition, spare parts, food, and maintenance equipment. This allowed them to stay at sea for long periods without resupply. The result was a cruiser heavy with logistics, not armor. Long-range communication and navigation systems. Global operations required reliable communication and navigation. Radio rooms, antennas, navigation equipment, and power systems added internal mass that did not increase firepower, but was essential for mission success. Extended hull and stability structure. The long hull improved seaworthiness and storage capacity, but a longer hull also required stronger internal framing, adding even more weight. County-class cruisers were heavy because they were built to endure distance, not punishment. 7. Deutschland class, battleship caliber gun systems. 280mm main gun system. The defining feature of the Deutschland class was its 6 280mm guns, battleship caliber weapons on a cruiser hull. These guns were massive, with long barrels and extreme recoil forces. Just mounting them required heavy reinforcement throughout the ship. Heavy gun turrets. Each turret housed thick armor, rotation mechanisms, and recoil systems. The turrets themselves were enormous concentrations of weight placed high on the hull. Ammunition hoist and loading systems. Handling 280mm shells required powerful vertical hoists and complex loading machinery. These systems ran deep inside the ship, adding weight from keel to deck. Heavy caliber ammunition magazines. Large shells and propellant charges required deep armored magazines with blast protection. These magazines were among the heaviest internal components on board. Cruiser-resistant armor protection. Because the ship carried battleship guns, it also needed armor strong enough to survive cruiser fire. The combination of heavy guns and matching protection pushed the ship far beyond normal cruiser limits. 6. Myoko class, concentrated offensive weapon systems. 10-gun 203mm main battery. The Myoko class carried 10 203mm guns, one of the heaviest cruiser broadsides ever built. Each gun required its own turret, loading system, and ammunition supply. Together, they created enormous internal weight. Type 93 Long Lance torpedo system. In addition to guns, these ships carried large numbers of Long Lance torpedoes. The torpedoes were heavy, powerful, and dangerous, requiring reinforced launchers and secure storage systems. Combined ammunition and torpedo storage. Few cruisers carried both massive gun magazines and extensive torpedo storage. Myoko-class ships did both, creating a dual offensive load that dramatically increased displacement. High-density structural reinforcement. So much concentrated firepower generated intense recoil and vibration. To absorb these forces, the hull was heavily reinforced. Myoko-class cruisers were heavy because they were built entirely around offensive power. 4. Tone class, aerial reconnaissance systems on a cruiser. Forward concentrated 208mm main gun system. The Tone class concentrated all 8 208mm main guns forward. This created a massive weight concentration at the bow, including turrets, gun barrels, ammunition hoists, and magazines. To compensate, the hull structure had to be redesigned and reinforced, increasing complexity and overall displacement simply to maintain balance and stability. Seaplane catapult launch system. At the stern, Tone-class cruisers were equipped with heavy steel catapult systems used to launch surveillance seaplanes. These catapults included launch rails, acceleration mechanisms, locking systems, and structural foundations designed to withstand repeated, high-stress launches. This system added significant mechanical weight without contributing direct firepower. Aviation fuel storage system. Operating aircraft required dedicated aviation fuel tanks, pumps, piping, and fire suppression systems. Aviation fuel is pure weight, and strict safety requirements added further structural mass. This aviation load did not exist on conventional cruisers and significantly increased displacement. Aircraft maintenance and recovery equipment. Cranes, lifting mechanisms, securing points, and maintenance areas were installed to recover and service seaplanes. These steel systems turned the cruiser into a partial aviation support platform, adding both weight and internal complexity. Reinforced aft deck structure. The aft deck was structurally reinforced to support aircraft operations and heavy aviation equipment. Reinforcement required additional steel plating and internal supports, directly increasing hull weight. 4. Takao class, extremely high weapon density. 10-gun 203mm main battery system. Takao-class cruisers carried 10 203mm guns, the maximum practical armament for a heavy cruiser. Each gun required a turret, recoil system, ammunition handling equipment, and armored magazine. As gun count increased, structural weight increased exponentially rather than linearly. Type 93 Long Lance Torpedo Weapon System. The Long Lance Torpedo System added a second layer of heavy offensive weapons. Large torpedoes, reinforced launchers, and protected storage areas contributed substantial mass. Because torpedoes were highly explosive, additional structural protection was required, further increasing weight. Improved armor protection system. Compared to earlier designs, Takao-class cruisers featured thicker belt and deck armor. Adding armor required additional internal reinforcement to support the steel safely, creating a chain reaction of increased structural mass. Large command and observation superstructure. The tall superstructure housed command spaces, optical directors, and observation equipment. This added significant top weight, forcing designers to strengthen lower hull sections to preserve stability. 3. Baltimore class, anti-aircraft and electronic warfare systems. Bofors 40mm anti-aircraft gun system. Baltimore-class cruisers mounted large numbers of Bofors 40mm guns. Each gun required a powered mount, ammunition storage, loading systems, and crew protection. In large numbers, these systems transformed the ship into a floating anti-aircraft fortress and added major weight. Oerlikon 20mm close-range defense system. The Oerlikon 20mm guns provided close-range air defense. While each weapon was relatively light, their sheer quantity added significant cumulative mass across the ship. Radar detection and fire control systems. Radar systems included antennas, control rooms, cabling, processing equipment, and dedicated power generation. These electronic systems added internal mass, but fundamentally changed naval combat by enabling long-range detection and coordinated fire. Anti-aircraft command center. This centralized control space processed radar data and directed anti-aircraft fire. It required large volumes of electronic equipment, operators, and electrical infrastructure, adding weight deep inside the hull. 2. Admiral Hipper class, complex machinery and protection. Boiler and steam turbine propulsion system. The Admiral Hipper class used powerful but highly complex propulsion systems. Large boilers, steam turbines, cooling systems, and extensive piping filled massive machinery spaces, adding heavy internal weight and mechanical complexity. Belt and deck armor protection system. German designers emphasized protection, fitting thicker belt and deck armor than many contemporary cruisers. Supporting this armor required reinforced structural framing, increasing displacement beyond the armor itself. Damage control and compartmentalization system. Watertight bulkheads, sealed doors, pumping systems, and fire control equipment improved survivability. These systems added internal structural mass that did not enhance speed or firepower, but was critical for staying afloat. 1. Alaska class, oversized weapon platform. 305mm main gun system. The Alaska class carried 9 305mm guns, approaching battleship caliber. These guns required massive turrets, reinforced barbettes, and deep ammunition handling systems, immediately pushing the ship far beyond cruiser standards. Large gun turrets and ammunition magazines. Oversized turrets, shell hoists, and armored magazines dominated the internal volume. These components represented some of the heaviest individual systems ever installed on a cruiser-type hull. Battleship-level armor protection system. Armor protection approached that of older battleships, including thick belts, armored decks, and a reinforced citadel. This added enormous structural and material weight. Heavy anti-aircraft weapon systems. Extensive anti-aircraft batteries, ammunition storage, and fire control equipment provided fleet defense, but significantly increased secondary weapon weight. advanced radar and fire control electronics. Next-generation radar and targeting systems required dedicated rooms, power supplies, and trained operators, adding a large electronic load to the ship. High-power propulsion system. Despite their size, Alaska-class ships were designed for high speed. Achieving this required extremely powerful engines and large machinery spaces, pushing displacement to unprecedented levels.